I started this CVT project because of mention of a rear pulley swap that could be part of a poor man's over-range transmission. In case you're not familiar with over-range CVT components, the idea is to extend the range of drive belt travel either for more speed or acceleration or both. When the belt is riding in the center of the front pulley and the outer edge of the rear pulley, this provides the best ratio for takeoff. Moving the belt further to the center of the front pulley or further to the outside of the rear pulley would create more range of low-speed gearing for stronger starts. When the belt rides at the outer edge of the front pulley and to the center of the rear pulley, this is the CVT's best speed ratio. If the belt could travel further outward in the front pulley or further toward the center of the rear pulley, you would have a greater range of ratios for potentially more speed. Gains in speed are often limited by engine output, so extending the drive ratio for max speed doesn't necessarily mean miles per hour will increase. Here's another view so you can see how the pulleys allow the belt to move by opening and closing. Companies like Malossi and Stage 6 sell complete over-range CVT kits that can increase belt travel on both ends. They're also designed to keep engine RPM within a more narrow range than stock and other CVT components may be capable of. This allows us to stay near peak power under acceleration for improved performance. Because each part is engineered to work together and for specific applications, setting up and tuning a kit can be much easier than piecing together individual components. One of the major downsides to a complete kit is cost. At the time of this video, I'm seeing complete kits from $400 to $600. This video will focus primarily on rear pulleys because I feel the overrange variator works well and you should be able to get one for $100 to $150, while some sites are selling overrange rear pulleys for as much as $400 alone. Before getting into the details of any CVT setups, it may be helpful to know what the test mule is. I'm using a Chinese Minarelli clone that started as a 49cc. It has a stock stroke Naraku crank, 68cc big bore kit from Autotech 355 on eBay with mild adjustments, a Leo Vents ZX exhaust, Malossi reeds, and a 21mm Del Orto carburetor. It's a very common mild street or sport setup. Unfortunately, it's not good for much over 50 miles per hour cruising, so you won't be seeing high speeds, but we can look at RPM and belt travel to see which setups control revs better at speed. Since we're going to check out possible alternatives to the expensive overrange parts, I thought it would be helpful to see how a complete overrange kit performs first. The kit I'm using is a Malossi overrange that I bought on sale from G-Force Power Sports for a little over $300 a couple of years ago. It included the overrange variator, rear pulley, and belt, as well as a few roller weights, a contra spring, and any spacers needed to make it all fit. The variator is 99.5mm in diameter versus 95mm for a stock variator. The rear pulley is a little over 128mm across, about 13mm larger than a stock pulley. The belt with my kit is 28mm longer and a half millimeter wider than the bando belts I normally use. The large variator allows greater potential travel for high speeds, while the bigger rear pulley provides a more aggressive takeoff ratio. Neither would work properly without the longer belt that's able to reach the outermost portions of each pulley. There are some complications involved with installing the overrange kit that standard CVT components don't present. The variator is not only larger in diameter but also much thicker. This allows it to use larger rollers and to have more travel, but leaves no room for electric start equipment. The starter clutch and gears must be removed, and in some cases it may be necessary to remove the starter boss as well. If you know you'll be using an overrange variator when building the engine, you may be able to tap the boss off from the inside so it's reusable. If the engine is assembled, you can carefully cut through the starter boss and then pull or pry it off. The stock spacer needs to be replaced with a shorter spacer supplied by Malossi. Anytime parts are swapped on this side of the crankshaft, you should pay close attention when installing the Kickstarter pawl. If the splines extend past the pawl, use spacers behind it until the splines are flush or slightly recessed. Otherwise, the front pulley cannot be secured properly and you risk damaging the crank and other parts. The Malossi torque driver uses two sets of straight grooves at different angles. Straight grooves help to keep RPM more steady compared to the multi-angle grooves common in stock torque drivers. Lesser angles allow shifting to happen easier, and greater angles require a little more effort to change ratios. The ability to choose the angle that works best for your setup and riding style allows for greater fine-tuning of the CVT. I installed mine using the dotted 40-degree paths. The other set is at 38 degrees, but I never tried them because initially this was only intended to be a quick test for a rough comparison, and I never planned to make a video. The Malossi spring base is a bit too big for stock Minarelli contra springs. They will fit, but they're tight against the base, which may encourage spring binding. Some companies produce springs slightly oversized to work with overrange pulleys, and 139 QMB or Honda Dio contra springs usually fit. I was using a Koso 1000 RPM contra spring for a 139 QMB or GY650 here. Before the clutch bell is installed, you should verify that the bell doesn't come into contact with the pulley's threads or the clutch nut. Malossi provides a spacer with some kits that may need to be installed between the bell and the rear pulley for proper clearance. Once the CVT is assembled, the cover may not fit. Some CVT covers are larger than others and leave more room around the rear pulley. Smaller covers could require material removal to create clearance. I was using a large cover at this point, but I'll show you more about making smaller covers fit later. My first combo used a 1mm spacer on the drive boss just as it was set up for daily riding before these tests. Installing a spacer at the end of the drive boss effectively elongates the boss and provides more clearance for the belt to ride low in the variator. This can improve takeoff, but sometimes hinders high-speed performance. Spacers must be the same outside diameter as the drive boss or slightly smaller. Larger spacers can't travel through the variator's bushing and become restrictors, preventing the pulley from closing completely. Some variators have enough room between the rear of the variator and the ramp plate that you can place spacers there to push the drive boss outward. In this case, the spacer can be larger as long as it doesn't need to travel through the bushing. You can buy spacers for some applications, but I use shimming washers available in sizes from 0.1mm to over 1mm thick. Their inside diameter matches the drive boss, but the outside needs to be ground or filed down to match. Be careful when using spacers. The variator has posts that the ramp plate rides on. If too much spacing is used, the ramp plate may separate too far. This can cause the ramp plate guide bushings to break, or worse in extreme cases. The overrange variator is a well-designed setup with extended posts and beefy bushings that isn't so vulnerable to this. Other variators without those attributes more commonly break bushings when spaced out. If the bushings break, you're left with metal-to-metal contact, which quickly wears away at the variator and makes a lot of noise. Keep all of this in mind when adding spacers, and remember that it may require some trial and error to find spacing that gives a good compromise between low and high-speed performance. Now we can move on to some tests, so let me explain what I did for each CVT configuration that I tried. When new combinations were installed, I did quick test passes to narrow down a small range of tunes that seemed to work the best. Then I took a 10 to 15 mile round-trip ride with each of those tunes. I rode sitting up as I would normally cruise to get an idea of real-world riding. In the middle of each ride, I did 4 timed 0 to 40 mph runs, 2 in each direction, using the same test spot every time. I averaged the 4 runs in an attempt to keep the results more accurate and consistent. Bear in mind, I'm a heavy rider and this is a mild setup, so the times you see won't seem very quick. I also used the marker to make a thick line across the variator before all test rides. The belt wears away the mark wherever it makes contact and allows us to see and measure belt travel. You could use the same trick on the rear pulley to check travel on that as well. Unfortunately, I didn't do that for these tests. Hopefully the combination of info will show what works and how various parts compare. The first setup is the Malossi Overrange kit with 7-gram roller weights, the torque driver set in the 40-degree grooves, a 139 QMB 1000 RPM contra spring, and a 1mm spacer on the drive boss. The clutch for all tests is stock with a Hoka bell, and for this test it's using 1000 RPM clutch springs. The Overrange kit did a good job of getting RPM up quickly off the line, even with such a tame clutch package. It settled in from 9,000 to 9,100 RPM up to 40 miles per hour, taking full advantage of peak output for this engine. Average 0 to 40 time was 11.48 seconds. RPM climbed to 9,200 to 9,300 RPM at 50 miles per hour, so the total spread from settling in after launch to 50 miles per hour was only about 300 RPM. I find that to be impressive for a CVT system that only requires basic tuning, and I may have been able to get an even tighter spread using the 38-degree torque driver grooves. Wide open throttle cruise speeds fell between 47 to 53 miles per hour, averaging about 50 miles per hour. I was left with a 2.81mm mark on the variator. Overall, a quick setup that was easy to tune and felt responsive and fun to ride. The next combo I tried was exactly like the first, except without the spacer on the drive boss. When the 1mm spacer was removed from the boss, I had to use a 1mm spacer under the Kickstarter pawl so the variator could be tightened down properly. Take a look at these pictures. One shows how the belt rides in the rear pulley with a spacer, and the other shows it without the spacer. Notice the belt rides further outward for an improved low-speed ratio when using the spacer. I perceived a slight difference in the initial takeoff, but otherwise nothing seemed to change. Same RPM from acceleration to cruise, same speeds, and practically the same belt travel. The major change was that 0 to 40 times increased by roughly 0.6 seconds on average. In this case, adding a spacer only had benefits. The next pulley is what started this whole project. Forum members mentioned Franco Morini pulleys as part of a poor man's overrange kit. As I understood it, they swapped right onto the Minarelli's primary drive shaft, and Minarelli clutches would fit to make it an easy upgrade. Scooter Parts Express was selling the whole assembly for $40, so I couldn't pass up the chance to check it out. When the pulley arrived, I compared it to a stock pulley, and it was about 7mm larger in diameter. I removed the clutch, which can't be used with a Minarelli, and noticed that the supplied contraspring fit tight on the spring base. I didn't like that much, but I noticed that springs for the Malossi overrange kit also fit the Morini pulley well. 139 QMB springs were a little too large for the base. I tried to slide the pulley under the drive shaft and it didn't fit. I really thought it would fit out of the box from what I had heard. The bearing at the back of the Morini pulley had a 15mm inside diameter, and the Minarelli shaft was 17mm. I removed the circlip from the pulley using snap ring pliers, then tapped the bearing out without much effort. There were also 2 spacers in there that I removed. The original bearing measured 15 by 28 by 7mm, so I bought a 17 by 28 by 7 bearing on eBay for around $10. I used a hammer and a socket that matched the new bearing's outside diameter, and it went in with just a couple of taps. Then I reinstalled the circlip. Then the pulley would slide on, but it hit the cast-in nubs on the case. I used a Dremel with a carbide cutter to grind down the nubs and to create more clearance near the top of the pulley. Then the pulley could slide on all the way, but it rubbed against the case. I started trying spacers behind it, but the Morini pulley, being thicker than the Minarelli pulleys, caused its outer bearing to sit too far out so it didn't make full contact with the drive shaft. There was a lip on the backside of the pulley roughly 60,000ths of an inch thick, so I ground it off to allow the pulley to sit further back. I placed the pulley on the drive shaft backwards and used the grinder to cut down the lip. The grinder spun the pulley for me so it was easier to remove material evenly. Then I sanded the edges smooth. Starting with a large washer to protect the seal, I stacked up about 1/4 inch of spacers to prevent the pulley from rubbing against the case. The pulley fit the shaft, spun freely, and the outer bearing made the most contact that I could get without a lot more effort. Next, I realized that the Morini pulley was a bit too small for the Minarelli bell. It would fit, but it was too tight and didn't rotate freely. I used a sanding drum and a Dremel to enlarge the center of the pulley until the clutch bell fit easily and moved without resistance. With any major fitment issues out of the way, I did a modification to be sure I would see the full potential of the Morini pulley. The grooves in the torque driver weren't as long as they could be and stopped the pulley from opening as far as possible. Here you can see the Morini pulley didn't open as much as a stock pulley that I had modified. I removed the pins and separated the torque driver from the fixed half. Then I removed the lower O-ring to be sure I wouldn't damage it. I used a carbide burr and a rotary tool to extend all 3 grooves downward so they stopped just barely above the receiver groove for the seal. Try to keep the extension straight and at the same angle as the original groove without widening the path. Reinstall the pins periodically to make sure the pulley opens properly and the pins don't hang up. It's very important to see if it works with all 3 pins installed. If not, you'll need to find which groove is hanging up and modify it so travel is smooth. Once you're satisfied with its operation, disassemble the pulley and file or sand the grooves so there are no rough edges. Then the pulley should be cleaned thoroughly before the O-ring is reinstalled. Apply grease, reinstall the pins and spring base, and make sure it still opens and closes smoothly. It wasn't an issue for me with this pulley, but sometimes other modifications are necessary to get max travel. Always open the pulley and verify that the torque driver and spring base don't come up above the top of the larger section of the shaft as shown. If they do, you may have to file or grind their tops until they're even with the shaft when fully open. Sometimes the top of the seal in the center of the torque driver sticks up too high. You may be able to use a razor blade to slice off the very top of the seal, but remove too much and it won't seal. Also, assemble the pulley and clutch without a contra spring in place and make sure the pulley doesn't hit the clutch. If it does, you may be able to remove material from the clutch or use a spacer to move the clutch up slightly. Back to the Morini pulley, I assembled it with an orange overrange contra spring and the same clutch parts as I used with the previous setup. I'm not sure what the rating of the orange spring is, but it's very similar to the 1000 RPM 139 QMB spring. I slid the assembly on and used a small washer under the clutch nut because it sat a little deeper on the shaft than stock and I wanted to be sure it tightened down properly. Again, I used the Malossi overrange variator and belt. The belt rested a little past the outside of the rear pulley, but it still had enough tension on it to work. Belt alignment was far from ideal. The Morini pulley sets deeper into the case than the Minarelli pulleys by probably 10 millimeters, but moving it further out would make the front bearing align even worse, so I stuck with it this way. After a little tuning, here's the first setup that worked well using the Morini pulley. Takeoff was a bit slower than with the overrange rear pulley, but not bad. It settled in at around 8,800 RPM and climbed to 9,000 RPM at 40 miles per hour. 0 to 40 times averaged 12.86 seconds, just shy of 1.5 seconds slower than the best Malossi overrange result. RPM rose to 9,200 to 9,300 by 50 miles per hour for a spread of basically 500 RPM from settled in after launch to 50. At or just after 50 miles per hour, it felt like another shift and revs would drop by 2 to 300 RPM, so I could be at 9,300 RPM at 50 and then 9,000 RPM at 51. Hopefully you can hear it happen in this clip. Unfortunately, it didn't lead to any higher cruising speeds. When it would pass 50 miles per hour, it was likely to stay around 51 or 52, but on average, cruising was 48 to 50 miles per hour. With a max cruise speed of 53 miles per hour, there was a 2.15 millimeter mark left on the variator, slightly more travel than I saw from the whole overrange kit. It seemed like a pretty respectable result for a cheap pulley, so I wanted to see if one quick change would help. I switched from 1000 RPM to 1500 RPM clutch springs, hoping to speed up the initial launch. 2000 RPM springs were too stiff and the CVT started shifting before the clutch engaged. It was 0.4 of a second quicker on average using the stiffer springs, almost exactly 1 second slower than the Malossi kit. Aside from launch, performance remained the same as the previous test. I only got up to 52 miles per hour on this ride and had 3.11 millimeters left on the variator. I also noted on a short test pass that I had a 50 mile per hour top speed and 3.42 millimeters left over. That info and the RPM drop after 50 miles per hour seem to suggest that it is shifting very quickly once past 50. That may make it good for high-speed cruising, but I didn't have enough power to support much beyond 50. I thought I'd also see how this combo would do using a stock belt, so I put on a Bando 788-1728. The same belt I normally use on CVTs other than the overrange kit. You can see that the shorter belt can't take full advantage of the larger rear pulley's low speed benefits. Mile per hour times increased by over a second from the exact same setup when using the shorter belt. Acceleration RPM remained the same, but RPM at 50 miles per hour increased to 9,300 or more. Max cruise speed was 50 miles per hour on that ride, and there was a 6 millimeter mark on the variator, so the short belt had negative impacts on both low and high speed performance. So far it looks like the Morini pulley could be a good cheap alternative with the right belt, but there's more to the story. I took one longer ride using the Malossi belt with this pulley because I was concerned about pulley misalignment causing belt wear. With test runs and the longer ride, I racked up over 100 miles and then checked the belt. It was glazed and worn a few tenths of a millimeter thinner in just that many miles. The Bando belt with even less miles was worn down by 0.3 millimeters and showed lots of glazing and cracking. Even the variator had accelerated wear. I can't imagine belts lasting long under these conditions, so this would make a lousy street CVT unless you could correct the alignment issues. Thinner variators used without electric starter components could cut a few millimeters off of the misalignment, but I'd still expect increased wear. With the pulley, bearing, and spacers, the Morini pulley set me back just over $50, but it would easily cost more than a genuine overrange pulley replacing belts before long as is. After talking about this pulley on the forum, I was told there are other models of Morini pulleys that fit without modifications, possibly from TGB or Aprilia scooters. I was also told that at least 3 pulleys with the same description from the same seller as I used have fit Minarellis without modifications. I'm not exactly sure what the deal is, but if you have experience with any of these pulleys, please post it in the comments below.